Hi all, welcome to this session. In this session, we will learn about the SysTick or SysTick Timer and a very important peripheral in all ARM Cortex microcontroller. So let's get started with today's session. So before starting with the core concepts of what is SysTick Timer, so let's start with some basics so we can understand it in better way and in detail. And it's very and this topic is very important for your interview. So I'm just going to add it to interview playbook as well. This is been asked in all of the most of the interview questions like what is SysTick Timer, how does it work, and tell us about what all registers are involved in that, all those things I will be covering one by one in this tutorial, right? So let's get started. So what does sys means here? Sys means system. Okay, literally what it means it belongs to the core system, right? So it belongs to the core system of ARM Cortex. Let's consider the system here, core system here, ARM Cortex microcontroller. Okay. Now, what does the tick word mean here? So tick word means is what? A small, regular time unit, right? I hope this is very easy to understand. I'm not going to give you the literal layman terms. It's already in the layman terms. I hope it is pretty much clear over here. Then coming to the word timer. Timer means what? It's a hardware component or block that counts the time. That what does it do? That counts the time. So like in seconds, it can be in milliseconds, it can be in microseconds. So it does the work of counting the time in with different units, correct? Okay. And as an embedded engineer, you must be familiar with this term, like the timer is the very important concept, and or the peripheral, we need to understand it in detail and it with accuracy, I would say. That's a very important topic. Okay. So now coming to the complete SysTick timer definition. So I'll just say SysTick. It's also known as SysTick timer. So what in layman terms, what we will say it is, it's a timer inside the system. Okay, system core that generates regular ticks. I hope this is pretty much clear. So I don't need to go into much details, but I'm just going to tell you how to, why I'm telling you in all these words by word, so that it's fitted in your mind, like it's fixed. Once you go through this video, if you revise once or twice, if you just go back once or twice, and it's in your brain, you don't need to worry about how it is going to stay in your brain or something. I'm going to make it very simple so that it is very easy to remember for your interview preparation, right? Okay. So coming to the next part of this session, we are going to cover the following main topics, right? So the following main topics are introduction to the SysTick timer. So we will learn about SysTick timer a bit, in technical words. So we understood the definition of SysTick timer in layman terms. Now we will understand the SysTick timer in technical words. Okay. Then we will be developing a driver. Then driver part we will study for the SysTick timer. And then we will also explore the registers associated with it. Correct? Fine. And by the end of the session, you will have a good understanding of the SysTick timer, and you will be able to effectively implement and utilize it in your ARM Cortex-M projects. So this SysTick timer is in all ARM Cortex-M microcontrollers. So it is whatever concept you're going to study in this session, it is applicable for all the ARM Cortex-M microcontrollers. Okay. So it is I'm going to make it very generalized, but definitely I am going to take up one code where I'll make you understand on particular one board, so that it's understandable to you all. Okay. Okay. The first part we will be starting is the introduction to our topic, SysTick timer. So what is SysTick timer in layman terms? You have already understood it. Like it's a timer inside the system core that generates what? Regular times or regular ticks. Okay. So it is what? It is the most or the core or fundamental component of all ARM Cortex microcontroller. right? And the processor which is the core of the system, the processor core can be Cortex M0, M1 or M7, and the silicon manufacturers can be of STM, sorry, let me erase that. So it can be of STM company, or it can be of TI or any other company. Okay, so another point to remember is every ARM Cortex microcontroller includes SysTick Timer. Correct? Fine. Okay, now let's understand a little bit more about SysTick Timer. So let's name it as SysTick Overview in terms of now technical details, right? The first point I want to mention here is this SysTick Timer. It is a 24-bit down counter built into all ARM Cortex. Built into all ARM Cortex, as I already mentioned this point over here. Now coming to the second point, it provides a configurable, consistent system time base across all Cortex-M devices. Okay, so now what the main point what I want to mention here is it is a 24-bit down counter. What do you mean by 24-bit down counter? So we know that the timer registers are of what, 31 bits, right? But the bits from 24 to 31 is reserved, right? And from 0 to 23 we can use it to count down. What is the countdown means? Let's say some specific number is there. Let's say 255 is the number we have, and it will count down to 254, 253, 252 and so on till 0. So this is known as countdown timer. It will be like this. It will move like this. If I want to show it, it will move like this. Okay, so this is known as 24-bit down counter. So now what is used for? Why do we use it, or for what applications do we use it for? So the first one which I would say is periodic interrupt generation, right? Then second application which I would say task scheduling. These are the main applications where the SysTick timer is being used. Okay, system monitoring, then fourth comes the time measurement and tracking. So I will give the practical application or real-time application as we go further in this session. Okay, now you know that this acts as a core timing component for implementing any system timing functions, and it is commonly used to generate the operating system tick in RTOS based systems. So what the system tick timer which you will come across is mostly with the RTOS. Also other applications like small applications are there where it will be used as a to generate a delay, as a countdown timer as well. So we will study one by one in the as we go further in this session. Now let's understand the key features of SysTick timers. So the first pointer I have already mentioned. It is a 24-bit reloadable counter. What does this mean? The counter decreases from certain value. Let's say this certain value is 255 or a particular value, and it decreases to 0 until it decreases to 0, and automatically when it reaches to 0 an interrupt is generated and it reloads the value to 255. So hence the name is 24-bit reloadable counter. I hope this is clear to you all. Then next is what? It is a second point is a very important point. So please try to understand. I'll just try to write a diagram as well. So just be with me. So it is integrated. What is integrated? So this SysTick timer has been integrated with the NVIC. So what is NVIC, guys? So I hope you know all this. It is a nested vector interrupt controller. Okay, and it can be used to generate SysTick exceptions. So exceptions can be, the interrupts which the OS in OS or the RTOS is required for some crucial task or some task to be completed or periodically which needs to be monitored. Okay. Now, so how is this concerned with here? So let me draw the diagram. I think it's on the internet as well. So it's very okay. So pardon, just don't mind my drawing. So I'm just going to draw something which is very understandable. So this is what every ARM Cortex has, this NVIC. In the in the datasheet also you have this architecture diagram over there. In that also you can observe this. So here there is an NVIC and it is associated with SysTick. SysTick is associated with NVIC. Okay, and there are some peripherals. Okay, there are clock systems and all those things come over here, or the interrupts, IRQs are all here, and this NVIC communicates with the core microcontroller and or the system things, whatever the architecture it has. I think this is what is there. So this SysTick timer is integrated with this NVIC and it's in the core in this Cortex-M microcontroller. I hope this is clear why I'm saying this is very important. So whenever there is interrupt generated, it will, because of this SysTick timer, there will be interrupt generated and it will communicate with this NVIC, the table over here, vector table over here, and then whatever the process is there, right, what happens next. Okay, fine. I hope this is clear to you all. Now the third point which is coming in the key feature is like it can operate either from the core clock or it can operate with an external clock. So it can be with the system core clock or it can operate with an external clock as well. So this is another feature of that. So we'll see in the further in the as coming up in the topics in this session. So also whenever as I mentioned over here, I'll just make it point over here only. Whenever the counter reaches to the 0, an interrupt is generated. Okay, and it triggers an interrupt and hence the auto reloadation happens post this. And what are the other processes? Those will be taken care of. Okay, so these are the key features of the SysTick timer. So now coming to the timer registers, SysTick timer registers. So we have 4 registers associated with this. So the first one is SysTick control and status register. And in the data sheet you can see it as SYS for sys and T for tick _ CSR, that is control status register. Okay, then the second register which we will be looking into in detail is like SysTick reload value register. So it is written in datasheet as SysTick CRVR. So that is reload value register. Then the third register, which is an important one as well, here it is SysTick current value register. So it is also known as SYSTCVR. So try to remember, you don't need to remember these things over here, SysTick, CVR or something, but at least you should remember what are the register names in the interview. And if interviewer asks what is the short form of that, then you can say, can you please provide me with a data sheet? And it's completely fine because you cannot remember all the names of the buses and whatever the short forms been used in the in a data sheet or of all the microcontrollers. It can differ with different microcontrollers, right? Definitely they won't ask, but sometimes an interviewer wants to check if you have really worked on these things or not. So then you can just reply to them that please provide me with a data sheet. Because I have worked on these things, these different microcontrollers and all those, right? Okay. Then the last and the fourth one is SysTick calibration value register. So it is known as SYSTCALIB. It is very easy to remember these things, but at the same time, when you are reading a lot of topics for an interview, different topics at the simultaneously, it's very easy to forget the terms. So make sure you are not burdening yourself with these short forms. Just say you need a data sheet. Okay. So now let's start with the first register. So what we had studied, what was the name? SysTick control and status register. Okay, also I will write the short form. If it is easily remembered by you, then just go with it. Otherwise, don't burden yourself with all these short forms and all. Okay, what does this register do? Okay, it controls the SysTick timers operation and updates the status of the updates the status as per whatever the information is there. Okay, so mainly we'll be using 4 bits over here, rest others are reserved. So let's draw the register here. So you know, this is the, in datasheet, if you open the datasheet you will get all these details. So this is the 0th bit, this is the 23rd bit, this is sorry, so this is the 31st bit, this is the 15th bit, this is the 16th bit over here, this is the 17th bit, right? So the first 0th bit is enable bit, then comes the next first bit is the tick interrupt, then comes the clock source. So this is 0, 1, 2, 3 over here, and then these are all registers reserved. Rest all registers, sorry, bits are reserved, not registers. Bits are reserved. Okay, so this one is the, let me rename it, this is the count flag. I will explain everything in detail, just be patient. So when this is clock source, this is tick interrupt bit, this is enable bit. Okay, so what does this enable bit do? So this enable bit is used to enable or disable the counter or the register or the timer. Okay, then this one, let's say if it is 0 it is disabled, 1 if it is 0 it is disabled, if it is 1 it is enabled. Okay, then comes the bit number 1, that is tick int. So it is also used to, you know, enable or disable whenever we want to generate an interrupt. Okay, when we generate an interrupt, when it reaches to the 0, the counter reaches to the 0 from the particular value or countdowns to the particular value, that time this tick interrupt will generate and it will be enabled. Okay, then comes the clock source. So here we select the clock, as you know, the internal, that is the system, or the external clock we will select based on that. So let's say internal is given 0 and 1 is given for the external. Depending upon our application, we will be selecting that part. And the 16th bit, that is the count flag, it tells that the counter has reached 0. It tells that it has reached 0 and the last, this is the last read value, and we have to check if it is 0, then yes, then generate the tick interrupt and then again reload the value. I hope this is clear to you. Let's move on to the second register, that is SysTick reload value register. Okay, now what does this do? It tells us, or it specifies, that the start value to load into this register, into the, sorry, not into this, into the current value register, and this is a very important for setting the timers period and understanding that this bit assignments and calculations for proper configurations. Okay, so remember that this is very important, setting the configuration, this part is very important to setting for the configurations. So here what we will be doing, we will be understanding how many ticks is required, what is the clock we are considering, all those things I will be telling you the calculation and all. Just wait for some time, have some patience. Okay, so before that we will understand the register. So now the bits from 24 to 31 it is reserved, and bits 0 to 23, it tells us that when the counter, let me write it down only, when the counter is enabled. Okay, when the counter is enabled, it tells the field that the value of the system tick will load, the system tick timer value will be loaded into what, into the CVR register. Okay, and also it tells, or you know, say flag is generated when it reaches 0. So okay, so what happens in these bits are used for by the counter, and it tells if it is enabled and loaded with the value which we will be calculating. It is calculated by the user or the programmer, or as per the application the value is being calculated, and this value is loaded to the CVR register, and it also tells that when the countdown when it reaches to 0. Okay, so now let's draw the register here. This is reserved, this is the 31st bit, this is the 24th bit, this is the 23rd bit, this is the 0th bit. So this value is always reloaded. Okay, and what do we mean by 24 bit now here? Okay, I forgot to mention it. 24 bit means 2 raised to 24 minus 1, that is the range. That will be the range. So what will be the range? It will be from 0 cross, let's say it is 0 0 0 0 0 0 0 1 to 0 cross 0 0 f f f f f f. So this will be the range of this. So try to remember this. Whenever they say 24 bit, it is 2 raised to 24 minus 1. Okay, and this is the structure of the register. Now let's calculate the reload value before we go to the next register. But I don't want to get you feel lost in somewhere. So let's do that now itself. So what we have to do, we have to calculate. How do we calculate the reload value? Okay. Now here what we do, we determine the number of clock cycles for the desired period. We have to determine the number of clock ticks or clock cycles for whatever the period we require. Let's say the requirement is, or the requirement sheet tells us, or the application which we are working on, or the driver which we we want to write about, it requires let's say it is for 1 milliseconds. Okay, and the clock core frequency, so the desired, let's write it down, it's better. So the desired period which we require for our application, let's say it is 1 millisecond. Okay, and the core clock frequency which we will be using is 16 megahertz, and we want the SysTick timer to trigger every 1 milliseconds. Okay, so every 1 millisecond this should trigger the interrupt, and the reload value will be loaded again into the reload register, SysTick reload register. Okay, so what is the number it will be counting? Like, let's say, as I mentioned in the earlier, right, let's say the value is 255, and from there it will go to 0. But now for 1 milliseconds we have to calculate this reload value. What is the end counting value? And from there it will down count, and when it reaches to 0, an interrupt is generated, right? So now let's do that. The formula for this is, let me take another color pen. So it's like clock cycles is equal to, what is that, 16 megahertz, right? That is 16 into 10 raised to 6 cycles per second. Okay, multiplied with 1, what is the desired value? 1 millisecond. So 1 into 10 raised to minus 3 seconds. Okay, now I'm going to be very, in layman terms, I'm going to make the calculation. So I'll just cancel out the seconds, and this is what this 6 becomes again 3. So it comes up to what? 16,000 cycles. It's very simple calculation. So whatever the we have the clock frequency given to us, or whatever the code, it's everything in the data sheet. So just select the clock frequency from the data sheet and multiply with whatever the desired time we require, so that the interrupt is generated every 1 millisecond. It can be microseconds, it can be seconds as well. So based on our application, or based on the requirement document, we will write the formula and get the number of cycles. So now the reload value here, it is always this minus clock cycle minus 1. I'll tell you why this is in the later. So it is what? So this is the answer. This is the value what we require. So it is what? 9,999. Okay. So what happens? It will count from 15,999 till 0. I hope this is very easy to remember. Now coming to the third register, it is what? SysTick current value register. So it is SYSTCVR. Okay. What does this register do? This register, it holds the current value. Whatever the current value it is counting, it will hold that value in the counter, and it is used to monitor the countdown process. it will whatever the value it is. Now let's say we had this 1599, right? So it will hold this value and then it will come to 15998. So then the current value is this, then 15997, this will be the current value. So these values will be held by the CVR register, and it will keep on monitoring the countdown process, and later it will reset the counter, and later it will reset the counter to reload the then the reload register will reload this value again once it reaches to 0. Okay, so now let's understand the structure of the registers. So the similarly to the previous one, it is almost same. So here it is 31st bit, that is the MSB. So this is the 24th bit, 23rd bit, this is all reserved. This is the current value. Here the current value will be held. Okay, it's very simple, nothing complicated. It's very easy. Once you know, you revise once or twice, repeating the same concept again and again will make you perfect in this topic. So the current value, what it does, it contains the current value, of the counter. Okay, and writing any value to this field clears it to 0, any field, I mean, and also the clears the count flag. Once it reaches to the 0, it clears the count flag also, and based on that and again the SysTick timer and the control status in the control status register, we will check the status of where our SysTick timer is being held. So these are all configuration, these all come in the configuration part, so we'll study more on this. The fourth register, it is SysTick calibration register. So it is SYSTCALIB. Okay, so what it does, it provides us with the calibration properties of the SysTick timer. Okay, so it's very simple. So we have now understood the 4 different registers. The first one is what? SysTick timer, control and status register, then the reload value register, then the current value register, and then the fourth one is the calibration register. Okay, so now what actually does happen here? Okay, now let me explain you why it is important over here. So let me make one chart over here, graph. So this is the based on the priority and based on our time. So we'll understand what is there. So let's say this is my system tick. This is my interrupts. These are my tasks or threads. Okay, now whatever in this OS, this is the, let's say this is OS, and it completes one task. Let's say it is a task A, and again it will go to the OS for certain period of time, whatever the time period is there, it will do that, and then again it will complete the task B, and so on and so forth. Again it will check the OS part, and task again it will go back. Okay, the system tick timer generates the interrupt request on regular basis. So the interrupts have been generated on regular basis, which allows the OS to carry out context switching. These are all what? Context switching. Context switching happens over here, and which will support multiple tasks. So the one task is being completed, then another task will be completed only after one task is being completed based on the priority, right? If it is task A has the highest priority, task B has the second priority, task C has the third priority. Okay, so let's understand the SysTick timer with the help of this diagram over on the screen, if you can just see. So what is the steps, or what are the important parts I have shown over here? Let's start one by one. The first thing which is very important over here, it is the clock. Select the clock source, internal or the system clock, or the external one. So if it is the internal, then let's say it is 0, so the switch will go to this 0 part. If it is external, if we are using external, so it will select the switch will select the 1. Okay, so this is the clock source over here. And then the second thing what happens is the reload value is being reloaded. You know that reload value, how it has been calculated. It is being calculated, I will write it again over here. System clock, whatever the system clock value it is there, into the time desired or the time which is required minus 1. Okay, if it is 16 megahertz into, let's say, 1 millisecond minus 1, it is equal to 15999, right? Okay, so this is the reload value which we will be uploading over here. Then what the current if you can see this current block, what is the current blocks does, it is empty. First, what we, whenever we are writing the code, we have to empty out this current value register over here. So whenever the automatically loads the reload values when the count is 0. Okay, and then when it reaches the 0, when the flag reaches, when the flag is like count is 0, the flag is been triggered, and then it reaches the 0. If it is 0, the interrupt is been triggered. Okay, so the interrupt has been triggered. So now this tick int will be enabled, right? And then again the reload value will be loaded with the value, whatever this value will be reloaded into the reload value. Again it will come to the current value, whatever the current value, let's say -1, whatever the current tick value will be there. Again once it is 0, the count flag will say that okay, it has reached 0. Now this tick interrupt will be reached, and then again the interrupt will be triggered, again the reload value will be loaded. So this enable is what, in the starting only we select the clock source, then we enable the status register. So okay, now we are starting the SysTick timer. So this is what it is, and how it works is, let me go down. So how this works is, so this is the counter. I think I have shown you, but still I'm going to show it to you. So this will be the count timer. It will go one by one. Let's say it is whatever it is, the count timer, it will go, and once it reaches the 0, here the interrupt will be generated. Interrupt will be generated. Again it will reload the value of whatever it is given, and again it will start to count down. Okay, and again once it reaches 0, again the interrupt will be triggered over here, again it will reload the value. Okay, so this is how the SysTick timer works. I hope this is clear to you all, and this session has been prolonged a little bit because I wanted to give you the whole concept of it. I just didn't want to leave half explained, or in a very hurry or in a short way. So a lot of interview questions will be asked on this. So this video has been a little bit longer than what I had expected. So please don't mind it, and so try to revise it again and again. And it is very simple concept. You just need to remember this diagram, the registers, and revise it, and it will be very simple for you. I hope everything is clear. If you have any questions, you can comment down in the comment section, and please don't forget to subscribe, share, and like my video, and also the bell icon, if you could just press it, so that you will get a notification about my next videos. I will be explaining it to you in details. I'll be using different methodologies to explain the embedded concept. So that's it for today, and I will see you in the next video. Thank you. Bye bye.